Hi, welcome back to another episode of Algebra in Words, the video series on YouTube. We're going to continue our discussion on scientific notation as well as exponent rules. And I have an interesting problem up on the board, one that you might have to do in your textbook. What I have here is three large numbers that we want to evaluate using scientific notation as well as the rules for exponents, if possible. So before we do the problem, let me explain what we're going to do and how we're going to do it, and then we'll do it. First of all, notice that we have three very large numbers. The first step here is we're going to convert each of these numbers into scientific notation. What you're going to notice when we do that is that we're going to all have then factors of base 10. And since we'll all have base 10, which are like bases, we're going to apply the product and quotient rules of like bases to those. And we're also going to kind of group the factors, and then we'll go from there. So you'll see how this plays out. Now again, the first step is convert each of the numbers into scientific notation. So for the top left one, 3 million, we're going to take the decimal here and move it 1, 2, 3, 4, 5, 6, and that's going to make this 3 times 10 to the 6. Now let's do the next one. 16,000, and if we move the decimal from the right to the left, 1, 2, 3, 4, we get 1.6 times 10 to the 4th. And now let's do the bottom one. This one is 8 billion. And so we're going to move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's going to become 8 times 10 to the 9th. Okay, now watch what we're going to do here. See how this is times 10 to a base 10, and times 10 to a base 10, and times 10 to a base 10? What we're going to do is, because remember the commutative property of multiplication means you can rearrange the order in which you multiply, and you'll still get the same answer. So just for a little space, I'm going to come down here, and I'm going to write the top ones like this. 3 times 1.6, and then I'm going to write times 10 to the 6th, and then times 10 to the 4th, the 10 to the 6th coming from here, the 10 to the 4th coming from here. Okay, so I wrote them as individual factors. And then below, on the left, I'm going to write 8 as its own factor, and then in parentheses, 10 to the 9th. Alright, so here's what I want you to do. I want you to focus on the non-base 10 numbers first by themselves, which would be the 3, 1.6, and 8. And then all the base 10 factors by themselves. Okay? So now that you've done that, this is what I want you to do next. Just sort of notice that we have 1.6 over 8. Okay? And you should notice that they have a common factor of 8. And if you did 1.6 divided by 8, you should get 0.2. So so just think of that in your mind a second. I'll write it here. 0.2. 1.6 divided by 8 is 0.2. And now, since we have 3 from here, multiply the 3 times the 0.2, and you should get 0.6. So I'm going to write over here 0.6, and we'll save that and then write what we get next. Now let's focus on just the base 10 numbers. Okay, and they're all base 10. They're like bases. That means that they're now eligible, that we can apply the product rule and the quotient rule of exponents because they have like bases. So first, let's do the product rule in the top. Base 10 6 times base 10 4 means we just can add the exponents. 6 plus 4 makes 10. So we're going to have, keep this in your mind a second, 10 to the 10 in the top. And now in the bottom we have 10 to the base 9. So now if you do the quotient rule and think of exponent 10 minus 9, then we get 10 to the power of 1, or you could just write 10. So thus far, everything that we've done has taken all of this and reduced it down so far to 0.6 times 10. And now to kind of finish the step, to finish the problem, we're going to multiply these together, and we're going to get 6, and you could say 6.0. And if the question wanted it in scientific notation, then we would say 6.0 times 10 to the power of 1, which would be, and actually the answer is just going to be 6.0 times, you could say times 10 to the 0, but if you remember, any base to the 0 is 1, so if you think of 6.0 times 1, you normally wouldn't write that, so you could just write 6.0. But if it specifically needed scientific notation, then technically it would look like this. But I think both answers are sufficient. So anyway, to summarize this problem, we were starting with 3 large numbers. In other problems, they could also be a mix of large and small numbers, but in this case it was all large numbers. We took the large numbers and we condensed them all into scientific notation. And then we separated the coefficients and put them out front, and we took out the parts that were times 10 to the exponent, the base 10s, and we kind of wrote them to the right. Then we kind of did the calculation of the coefficients first, and we were able to simplify that down to 0.6. And then we focused just on the base 10 factors. And using the product and quotient rules, we quickly simplified that down to just 10. Then we multiplied them together and got 6. If you put it into scientific notation, it's times 10 to the 0, because 10 to the 0 is 1. And you could also just say 6.0. So anyway, I hope you found that video helpful. If you did, make sure you hit the little bell to the bottom so that you can be alerted when new videos come out. And also, be sure to share with your friends. Give a thumbs up. Please leave any feedback in the comment section below. And also check out my other videos on Facebook and Instagram. And I'll see you in the next video.